Hey everyone, and welcome back to the Curious Engines. This is the place where we turn on our curiosity and explore through it, one fascinating topic at a time. And today, we need to talk about 3I Atlas. Right now, on November 17th, 2025, the entire astronomy world is shaking. Because in the last few days, new research, new images, and new analysis have exposed something so unusual that the standard comet explanation is starting to fall apart. I'm talking about razor-sharp, sunward jets, impossible timing, strange chemistry, massive acceleration, and behavior that simply refuses to match the laws of comet physics. And yes, new scientific articles have been released this week that push the debate into a new level. 3I Atlas did not enter the solar system like a normal visitor. Its path came in on a retrograde orbit almost aligned with the main plane of the planets. That alone is rare. But the timing of its arrival placed it passing close to Mars and Venus, and then reaching its closest point to the Sun exactly on the far side, hidden from direct observation. Astronomers call that unusual alignment. I call it suspicious timing. As soon as 3I Atlas was discovered, Hubble captured early images showing a compact body wrapped in a strange glowing haze. At first, it looked simple, another interstellar rock drifting by. But then the data started acting weird. Its brightness jumped faster than normal comets, its color shifted bluer than the sun. Its rotation speed did not match the jet patterns people expected, and its path through space refused to stay exactly where gravity predicted. By late October, people were already debating what was going on. But then, November happened. On November 9, two German astronomers released processed images that shocked researchers around the world. These images show long, needle-straight sunward jets stretching more than 1 million kilometers. Yes, 1 million, directly into a solar wind that should tear those jets apart instantly. This is where physics raises its hands and says, no. A natural comet spins. 3I Atlas rotates every 16 hours. Material shooting out of a rotating body would smear into curves, spirals, or wide fans, not straight beams. But these jets from 3I Atlas are perfect, sharp, stable, locked in position like they are held in place by a guidance system. To travel 1 million kilometers, the gas would take about 1 month. In 1 month, the comet would rotate dozens of times. Yet the jets do not twist, do not blur, do not bend. This alone breaks the idea of a normal comet. Now let's look back at the extreme acceleration, that sudden shift in its path near the sun. In a normal comet, this rocket effect is caused by outgassing. The expelled material acts like a thruster, pushing the nucleus in the opposite direction. To explain the size of the non-gravitational acceleration measured on 3I Atlas, a colossal amount of mass must have been ejected. Calculations show that a natural icy body would have needed to lose a minimum of 10 to 13% of its entire mass during that event. But again, the data doesn't match. If 13% of its mass was lost, it should have generated a vast, highly visible cloud of dust and gas that would have caused the object's core to dramatically dim, or it should have broken into fragments. It did not dim, and it did not break apart. The acceleration is not explained by the whole of the ejected mass. Because the jets are shooting out in multiple, complex directions, including jets pointed away from the main direction of the push, most of the mass loss is actually canceling itself out. Only a tiny fraction of the total expelled mass is pushing it in the desired direction. This means that for a natural comet, the amount of mass required to achieve that acceleration, given the multiple competing jets, becomes astronomically huge, far more than its estimated size could contain. It defies the law of conservation of momentum for a natural, chaotic, outgassing process. In short, too little mass was lost to account for the massive acceleration, unless the material was expelled at an unprecedented velocity, or the push came from a highly controlled and efficient source, like a propulsion system. Let's talk about what 3I Atlas is made of. Some early studies showed that the gas plume has an unusual chemical mix, very low water content, strange metal patterns, and ratios that are unlike anything in our solar system. Some scientists describe the mix as industrial-like. Most comets are ice with dust. This one looks more like metal with a little ice. In short, it behaves like a dark, rocky object pretending to be a comet. The strange, brightening. Near its closest point to the sun, 3I Atlas brightened faster than physics predicted. Brightened too fast. Brightened in a way that made the dust look hotter and bluer than expected. Some astronomers suggested it was fragmenting, but it did not break apart. There was no debris cloud, no fading afterwards. Instead, only one thing happened. Its path changed. A lot. The massive acceleration. Around the closest approach to the sun, its trajectory suddenly shifted more than any other non-sun-grazing comet in recorded history. That shift implied that a huge amount of material must have been expelled. But here's the catch. If a natural comet lost that much mass, it should have dimmed. But 3I Atlas did not dim at all. So either it lost mass without losing brightness or something pushed it. And after that event, it started flying like it was controlled smooth. Stable, no wobble. Natural comets wobble like crazy after big outgassing events. This one flies like it's on rails, why the natural explanation is failing. Some scientists tried to compare 3I Atlas to two older comets. One example was a huge comet called UN-271. Another example was Comet K2, but those comparisons break instantly. UN-271 showed sunward dust at 20 times Earth's distance from the sun. A place where solar wind is extremely weak. Move that same dust inward toward the sun, and the jets collapse into a tiny blur. Nothing like what we see from 3I Atlas. K2 had sharp jets too, but it rotated so slowly that nothing smeared, and all its jets pointed away from the sun. That's normal. 3I Atlas is completely different. It rotates moderately fast. It shows jets facing the sun, the hardest direction, and the jets stay straight for 1,000,000 kilometers. This is why even calm astronomers are starting to admit the obvious. They focus on the jet structure, rotation timing, and the lack of smearing. The findings are simple. If the jets were natural, they would blur. They don't, so something is stabilizing them. Another article highlighted that after the big acceleration event, the path of 3I Atlas became unusually clean and precise, almost controlled. These papers do not say the word artificial, but they clearly show that the standard model of a natural comet no longer fits the bigger question. None of this proves 3I Atlas is a probe, but refusing to consider the possibility is no longer scientific. If we keep saying normal comet every time something strange enters the solar system, we will miss the moment when something truly extraordinary arrives. "3I Atlas had a perfect chance to enter a stable orbit around the sun. It didn't take it. It's leaving. But the next object might not leave. It might slow down. It might match Earth's orbit. It might stay. So what do? We demand observation time. We demand telescope tracking. We demand radar. We demand spacecraft missions, even long-term ones. Because the universe doesn't care about our comfort. It doesn't care about our assumptions. It only cares about reality. And reality is telling us that 3I Atlas is not simple. If this deep dive opened your eyes, smash the like button and subscribe to the Curious Engines. I bring you updates the moment new data drops. Stay curious, stay alert, because the universe is full of wild, impossible, breathtaking surprises. This is the Curious Engine, signing off. Keep driving your curiosity.